This time, hypothesis testing still, but using the p-value method. So the p-value, or the probability value, is the probability of getting a sample statistic, such as the mean, for example, or a more extreme sample statistic in the direction of the alternative hypothesis when the null hypothesis is true. So the idea for the p-value is, instead of comparing the critical value with the z-score, we are comparing directly the significance, the level of significance compared to the chance of committing a type 1 error. So for example 86. A researcher wishes to test the claim that the average cost of tuition and fees at a 4-year public college is greater than $5,700. She selects a random sample of 36 4-year public colleges and finds the mean to be $5,950. The population standard deviation is 659. Is there any evidence to support the claim at alpha of zero point 0? Right. Use the p-value method. So the null hypothesis is that it is equal to 5700. And the alternative, the alternative is that it is greater than 5700. Okay, so for the z-score, x bar minus mu divided by sigma, and the sampled average is 5950. 5950 minus 5700 divided by 659, square root of how many samples? 36. The value of this is 5950 minus 5700 to 50 divided by 659 divided by square root of 36, and that is 2.28. 2.28. Okay, so 2.28. So we're going to draw this, since this is right tail. This is z 2.28, and we know the significance level to be 0.05. In the traditional method, we convert the significance level into the critical values and compare that to the z-score. In p-value method, it is the opposite. We convert the z-score into probability value and compare it to significance level. So let's look at the table and find out the value of 2.28. So 2.28, this is 2.2. Okay, 2.2, and then the 8 is here. So this is 2.28, 0.4887, 0.4887. So the value is 0.4887. So this is 0.4887. Therefore, the remaining area is 0.0113, right? So 113. And since this value is less than alpha, which is 0.05, meaning this value is within or falls in the critical region. In the critical region. It's like saying your chance of committing a type 1 error is only 5%, but given the data or the information that you have, your chance of committing a type 1 error is actually 1.13%, which is lower than the allowed probability to commit error. Therefore, the conclusion is to reject the null hypothesis. Okay, do you understand? So, in order to reject the null hypothesis using the p-value method, the corresponding probability of the z-score must be less than the allowed chance to commit an error. Okay, so let's continue. A clear distinction between the alpha value and the p-value should be made. The alpha value is chosen by the researcher before the statistical test is conducted. Correct. The p-value is computed after the sample mean has been found. That's what we did. There are two schools of thought on p-values. Some researchers do not choose an alpha value but report the p-value and allow the reader to decide whether the null hypothesis should be rejected. Okay, so they do not choose the alpha but report the p-value. In this case, the following guidelines can be used, but be advised that these guidelines are not written in stone and some statisticians may have other opinions. Okay, so let's read the guidelines. First, if p-value is less than or equal to 0.01, reject the null hypothesis. The difference is highly significant. If the p-value is greater than 0.01 but less than 0.05, reject the null hypothesis. The difference is significant but not highly significant. If the value falls within 0.05 and 0.1, consider the consequences of type 1 error before rejecting the null hypothesis. And if the value is greater than 10%, do not reject the null hypothesis. The difference is not significant and may be due to chance. Okay, so if a researcher selects, for example, 1% or 0.01 level, significance level, and the p-value is 3% or 0.03, the researcher may decide to change the alpha value from 0.01 to 0.05 so that the null hypothesis will be rejected. So, in other words, if you have already set the value of significance level or alpha from the start and you change it in order to reject the null hypothesis, that is not allowed. It should be set before the hypothesis testing because otherwise you are manipulating the data. Okay, so let's continue.